So we're looking to solve this integral here. In order to do that, we're going to want to make a transformation first, and then we're going to convert it to spherical coordinates. So let's go and plug in the values in for this equation here. And we'll see that it'd be more like 4u squared over 4 plus 16v squared over 16 plus 100w squared over 100. That's going to equal 1. These things will all cancel out, and we're just going to get u squared plus v squared plus w squared equals 1. So that's kind of cool. We'll also use the Jacobian transformations here. So we will say that dx equals 2 du, dy equals 4 dv, and dz equals 10 dw. We could put this into a matrix that says dx, dy, and dz are going to be equal to basically a 2, 0, 0, 0, 4, 0, and a 0, 0, 10 with a du, dv, and a dw here. Then we can solve this little piece by saying it's 2 times 40. And then there's going to be the du, dv, and dw on this side, which equals dx, dy, and dz. So 80 is our determinant here. That's fine. And that's going to basically go in here. Okay, so we'll have 1, 2, and then 3. I'm going to replace this whole situation with this. So we'll go 1 minus u squared plus v squared plus w squared. And then that's going to be replaced with this 80 du, dv, dw. And as far as these things go, let's wait on that. The reason why we're going to want to convert this to spherical coordinates is, let's try to draw this. Kind of like that. This would be the u, v, and w. We've already gone from the x, y, z and converted into here. And we'll see that if we just look at this equation, u squared plus v squared plus w squared equals 1. I mean, that's the equation of a sphere with the radius of 1. So we've got 1, 1, and 1. And this is essentially what that looks like. So it's just a sphere. And that's why we're going to use spherical coordinates. So spherical coordinates say that it would be something more like rho squared, like if we were to do du, dv, dw, that would be rho squared sine phi, and then d rho, d phi, d theta. Just converting that into that. We'll put the 80 over here somewhere, because we're going to want to start doing our next triple integral. We're going to keep this in there. But now we're making the substitution that p squared equals u squared plus v squared plus w squared. So we can just put this in right here. All right, so we're getting there. We've got all this inside of our integral. If we wanted to figure out what the whole volume is for the entire sphere, rho goes from 0 to 1. The phi thing goes from 0 to pi, and the d theta goes from 0 to 2 pi. That's going to be all of that. So let's solve this using the substitution. We'll go sine squared plus cosine squared equals 1. And then we'll just go cosine squared equals 1 minus sine squared. So we can see that we want p to be equal to sine. I'll make it sine of q. So that way we can go dp equals cosine of q dq. Now we can plug this stuff in. So when we get 1 minus p squared, if 1 minus sine squared, it would become cosine squared. Square root that, you'll just get cosine of q. And then there's going to be the p squared, which will become sine squared. Then you've got your sine of phi. Then you have the dp. That would be cosine of q dq. Then you have d phi. Then you have d theta. Now we can set our limits. 0 to 2 pi, 80. All right, so we're getting a cosine squared q, a sine squared of q, a sine of phi in there, dq, d phi, d theta. Oh, well, this is interesting. I do seem to remember that 2 cosine sine equals sine of 2q. So I'll go ahead and do that. But I also want to make sure that I don't do anything wrong. So I'm going to put the 2 on that side. And then I'm going to square everything. So that'll just become a 4 down there. So this can be replaced by sine 2q squared. And then 80 divided by 4. I'll just put that as 20 somewhere over here. We have 0 to 2 pi, 0 to pi, 0 to 1. There's still a sine, a phi. We're still looking to do dq, d phi, and a d theta. But the sine squared can become 1/2 minus 1/2 cosine of 4q, as far as I know. And now we have a chance at doing the dq. We could pull the sine of phi out somewhere. Got a couple of integrals here. There's still going to be a 20 in there somewhere. Finish this off. And now, let's integrate over dq. So we'll get q over 2 minus the integral of this is going to be more like, if we cover that up, what is the integral of cosine? Should be sine. So we'll get technically 1 over 8 sine q, and that should be a 4q in there. 4q. Now the q's, this was supposed to be 0 to 1 for p. But if we look at the q, let's look at this. If 0 is going to be p, then sine would also have to be 0. So we'll go 0 for q. And then if I wanted 1 out of p, then sine would have to be pi over 2. So I'll put that for the dq. And we're still looking at a couple of other things over there. This is just going to always go from 0 to pi and 0 to 2 pi. So there's nothing too crazy happening over there. And should be able to finish this up here. This will turn into pi over 4. And if we plug in the pi over 2 in for that, that'll just become 0. So I think that's the answer to that integral. And it seems we have lost our sine of phi somewhere, but I'll go ahead and stick that in there as well. That was just supposed to be a constant. So we're going to want to integrate that now. Sine of phi. We're at that step. This is going to be 0 to pi for the sine of phi. So, let's see if we could do this. The integral of sine is just going to be negative cosine. So we'll go over here. Negative cosine of phi. There's a pi over 4. There's a 20 over there somewhere. And there's another integral somewhere from 0 to 2 pi. And this one was going from 0 to pi. Now, if I go from cosine of pi, that's going to be negative 1. But it's going to be a 1. And then I'm going to subtract a 0, which is supposed to be, cosine of 0 is 1. But it's going to be negative 1, so it's going to be positive. So it's going to be plus 1. There you go. So you get 2 out of that integral. Out here, there's going to be like a 5 pi somewhere. But I'm not done. I still have to integrate one last piece. Because we're integrating 2 from 0 to 2 pi with d theta. So we'll go ahead and just multiply that. This is going to turn out to be 4 pi. And then we have the 5 pi on the outside. So the final answer should be 20 pi squared. And there we go.